Setting up AI locally on your laptop can seem tricky at first, but once you've got the right hardware, it becomes totally doable. So, you've been watching all these amazing AI videos and thinking, I want to run AI on my own laptop and experiment with it. In this video, we'll break down exactly what kind of hardware you'll need to get started with AI locally, whether you're aiming for basic testing or full-scale model execution. When we talk about setting up AI on your laptop, we're referring to creating an environment where you can run powerful tools like large language models, LLMs, or other open-source AI systems. This means installing and configuring everything needed to load, run, and interact with these models locally. So, what does that setup actually involve? First and foremost, you need a fairly recent CPU. Now, if you go to the website of any of these open source models, they will have a README file that talks about the hardware requirements. I'm using a 13th generation i7 from Intel. It's a fairly recent processor, and it works great for running these models. So if you have anything newer than a 10th generation i7 or i9 or a Ryzen 5 or Ryzen 7 from the last 2 generations, you should be good to go. Next, let's talk about the motherboard, the backbone that connects all your computer's components. For running local AI models efficiently, you'll need a relatively recent motherboard that supports PCIe Gen 4 PCIe 4.0. This is crucial for getting full speed from modern GPUs. Most AI model repositories, like those on GitHub, include hardware requirements in their README files. Be sure to check those. For example, I'm using an ASUSB 760 motherboard, and it works great. Not sure what motherboard you have? Just Google "what motherboard do I have?" You'll find free tools that identify it instantly. Next up is RAM, a critical component when running AI models locally. I recommend at least 30 gigabytes of RAM, though some smaller models can work with 16 gigabytes. However, more RAM allows you to handle larger models and longer prompts more smoothly. In the world of AI, tokens are the chunks of text models process. More RAM means more tokens can be handled at once, especially important for chat models and long-form generation. As a rough estimate, 30 gigabytes may allow you to handle 4,000 to 8,000 tokens, depending on the model size and backend. 64 gigabytes or more opens the door for larger models and longer interactions without memory errors. Finally, let's talk about the GPU, the most important hardware for running AI models locally. While it's technically possible to run small models on a CPU, a dedicated GPU will drastically improve speed and performance. It's highly recommended. I personally use an NVIDIA RTX 3080 with 10 gigabytes of RAM, and it handles most models very well. If you're using a 3080 12 gigabytes, 3090 24 gigabytes, or even an AMD card with high RAM, you'll be able to run larger models and process more tokens per prompt. The key thing to remember is, more GPU memory VRAM equals more model capacity plus longer token limits. Also, ensure your GPU supports CUDA for NVIDIA or ROCm for AMD if you're planning to run models in frameworks like PyTorch. So, those are the core hardware requirements. Once your setup is ready, the next step is to download the code for the LLM large language model you want to run, like Llama, Mistral, or Phi. The Memoxi team will guide you step by step from downloading the model code, configuring the files, and finally running your very first prompt locally. And this is just the beginning. Over time, we'll release advanced AI tutorials walking you through image generation, video synthesis, and much more, unlocking the full potential of local AI. Got questions about the hardware or setting up AI locally? Drop them in the comments below. We're here to help. We're also preparing a step-by-step video guide to show you exactly how to install and run these models on your own machine, so stay tuned. If you found this video helpful, give it a thumbs up and consider subscribing for more content on AI, machine learning, deep learning, and beyond. Thanks for watching, and we'll see you in the next one.